All right, so for no good reason, I'm going to do this one backwards. This is your twin for your chapter 6 and logarithms, sequences and logarithms test, which is on Valentine's Day. Sorry about that. This one, there is no way to change 10 into a base of 2, at least easily. I mean, there are ways of doing it, but we're just going to do a simple technique. It's called ln both sides. And this actually does kind of do the conversion. This creates the base we need. So we'll introduce an ln on the left. I'm going to wrap that 10. Oops. Ln of 2 to the 4 minus x. And, you know, we have to memorize our properties. We have a property that says a logarithm with an exponent of r. We can move that r out front, turn into a factor. So we're going to move these numbers out front. Now, my ninth commandment of math says 2 or more things we wrap. A lot of kids don't like to wrap that, and that causes the issue. 4 minus x goes out front. We have to learn how to write properly. It's part of it. We're going to use what's called the distributive property here. 3x natural logs of 10 is, oh, no, Milbrath, no, wake up. 3x natural logs of 10 minus 8 natural logs of 10 is equal to 4 natural logs of 2 minus x natural logs of 2. All right, so now we're going to go back to when we first learned algebra. We're going to take everything with an x and place it on the left and everything else on the right. So we're going to move this, leave that guy there, and we're going to move this guy over here. So next line, 3x natural logs of 10 plus x natural logs of 2 is equal to, this guy's fine where he is, 4 natural logs of 2, moving over, plus 8 natural logs of 10. Your favorite F word, if you're in an Algebra 2 class, is factor. Both of these guys contain an x. And there's nothing you can do with this stuff over here unless you go to a calculator and push buttons, which you're welcome to, but it's not what we do. Now, to isolate this x, the opposite of multiplication has always been division. So we're going to divide both sides by 3 natural logs of 10. And if we do it to the left for purposes of equality, we must do it to the right. And there you go. Yeah, it says it's the easiest one up there. It kind of is. Not. All right, bonus 3, solve this one. This used to be, you know, part of our standards was getting kids to factor stuff like this. It was a pretty typical question back around 2016, 2017, you know, back in the time before the iPhone 12, which I think we're on the 16 now because I just bought my wife one at Christmas. Anyways, why am I putting a 5 to the x and a 5 to the x there? I'm putting a 5 to the x and a 5 to x there because that is 5 to the 2x because we add the exponents, which is a 5 squared to the x, which is 25 to the x. That's why I'm doing that, because that's what it is. To get to a 16, I need 4s. And they're both negative because a negative times negative is positive, and I need to add to negative 8. Negative 4 plus negative 4 is negative 8. So now we're going to use the zero product property. 5 to the x minus 4 is a 0, and there's no point writing it twice because, you know, whatever. Anyways, I just add 4 to both sides, and then I do log is b, which is something I'll do a lot on this sheet. A logarithm base b argument a equal to something is or has an equivalent inverse of b to the e equal to a. So we're going to do this bottom up. I have a logarithm of base 5. Its argument is 4, and that equals x. And now in order to push buttons in a TI-84, we're going to do change of base. Change of base would be a logarithm base b argument a, I like ln, is ln of the argument over the ln, or the natural log of the base. So the natural log of 4 is going to get divided by the natural log of 5, and that is my x value. I would also accept log of 4 over log of 5. I would not accept the decimal. I wouldn't, because I'm like that. All right. Solve log base 4 of x equals log base 16 of 3x. The issue here is the bases are not the same. And this one is actually going to be pretty easy. I probably did this harder on the last one. I'm just going to make this guy a log base 4 of 3x over a log base 4 of 16. Now, log base 4 of 16 is asking me what power of 16 creates, or what power of 4 creates 16. But, you know, as much as I've tried to get y'all to read logarithms the same way I do, you're not. This is a 2. All right, that is a 2. So let's multiply both. Let me read out what I have real quick, and then we'll talk about the next step. There's 2 valid moves that you could make. And the easiest one is probably to multiply both sides by 2. Now, where does that 2 belong? Just a few minutes ago, I talked about a property where exponents go out front. The same exact property says put an exponent up there as a square. So a log base 4 of an x plus 1 quantity squared is equal to a log base 4 of a 3x. All right? Now here's what I know. I have a property that says if I have 2 logarithms with the same exact base, the arguments inside must equal each other. That's one of the other properties of logarithms we have. So x plus 1 quantity squared must equal 3x. You know, if Jesus saw this, Jesus would FOIL. We've talked about that. So we're going to write x plus 1 twice. Hopefully, you are a kid who can do that entirely in your head and not say x squared plus 1. Don't be that kid. Tired of that kid. I see that kid every year, man. Every year I see that kid. And I just don't know why that kid just continues to be in my math class. It's a constant insult. Anywho, ranting aside, this is going to give us x squared minus x plus 1 is nothing. Now, I know this isn't going to factor, so I'm just saying x equals negative b. B is negative 1. Plus or minus square root b squared minus 4ac all over 2a. And I'm going to figure out what's in that radical. I forgot my little square there. You know, this creates a 1. Take away 4 is negative 3. X equals 1 plus or minus the root of a negative 3. Both pieces over 2 times 1, which is 2. We clean this up using the concept of imaginary numbers. 1 plus or minus I root 3 over 2. Neither one of those work. I mean, they're both extraneous. So this one had no real solutions. They just weren't present. And the next bonus, which I think is the easiest one, to be honest with you. But then again, I understand exponents, so that has a lot to do with it. Solve for x. Log base 3/2 of 8/27 is equal to x minus 4. And there's lots of ways of doing this. Here's one way. Just do log as base, argument, exponent. Or is this the only way? This might be the first thing you have to do. Forgive me. But 3/2 is going to get raised to the x minus 4, and it's going to equal 8/27. Yeah, there's only one thing we can do. Now, if you have some number sense, 8/27 is 2 cubed over 3 cubed. It looks kind of like 3/2, doesn't it? I can think of that as 2/3 cubed. If I made the exponent negative, that would flip the fraction. So, you got to have the ability to manipulate numbers. That's all math is just straight up manipulation. There's my setup. X minus 4 is negative 3. Add 4 to both sides. X is 1. This was one of the bonus questions on the last test, and I think 5 or 6 kids got it, out of 70. Not a very good percentage, but it happened nonetheless. All right, 22. How many terms of the series created by the sequence a sub n is 1/2 times 2 to the n are required for sum of 57,344? P.S. The first term is not 1/2. So I'm going to write down my formula for summation. That's where I'm going to start. And this is geometric. We have a ratio of 2. And there's my formula I'm going to use. So what do I know? I know I have a known sum, and it's 57,344. If you see old Dalton Dean, tell him to start paying attention to what's going on. There's your call out, Dalton. I know I need the first term. See that first term there? So let's plug in a 1. And 2 to the first is 2. So this is a half times 2, which is 1. So the first term is 1. 1 minus the ratio. The ratio is always the guy with the exponent. The ratio is a base, is what it is. And it's a 2. And I don't know n. This is 1 minus 2. And then I just kind of work some things out here. If I do 1 minus 2 here, I'm going to have a negative 1. I've got a 1 out front too, by the way. 1 minus 2 again. All right, so if I divide these guys by a negative, I'm going to have a negative 1. And since this number is not negative, this is a 2, and it's technically in parentheses, okay? That's going to make this become plus 2 to the n. Still equal to 57,344. The opposite of subtraction is addition. Something seems wrong here. I guess I can't do it that way. Huh. Okay, let's divide the negativity out of both sides. So negative 57,344. Oh, it's fine. I'm just having a moment here. I don't feel like I am. Well, let me go back to what I had. Something just doesn't feel right. So this is going to give me negative 1 plus 2 to the n equal to 57,344. I'm going to add 1. This is why I'm having a problem here. 57,345 equals 2 to the n. I'm not going to get a whole number of this. I have a problem with this. 5, 7, 3, 4, 5. Oops. Anyways, I'm doing log as bay here. So, yeah, ln 5, 7, 3, 4, 5 divided by the natural log of 2. Yeah, let me pause this, see what the problem is, but there's a problem somewhere. If I have to edit it out, so be it. So you guys will never see this, but the problem is this is supposed to be 3, 2, 7, 6, 7. There is no way to get a sum from that sequence. 3, 2, 7, 6, 7. So it's an easy fix. And I don't even have to change that much stuff. That's going to make this 3, 2, 7, 6, 7. And we're going to add 1. 3, 2, 7, 6, 8. All right, cool. Now we're in business. Base, exponent, argument. So a logarithm of base 2, whose argument is 32,768. I know this works because I know my powers of 2, is equal to n. So change the base on this one. ln 32,768. I wish I would have caught that earlier and saved y'all some time. I'm sorry. It's 15. It's 15 terms to create that. There's other ways of doing this, and some teachers probably teach it, but it's purely technology based, and it's not really teaching a kid how to do anything other than use a calculator. All right, how many terms of the series created by the sequence a sub n is 3x minus 2, and I should say 3n minus 2, whatever, required for sum of 925. So I know that this looks like mx plus b, so that means it is arithmetic. That's what it means, it's arithmetic. So for arithmetic, the sum of n things is the first term. Sorry, that's not it. Sum of n things is n over 2 times the first thing plus the last thing. And I don't know what n is, but I do know that the sum is 925. Must be equal n over 2. I can find the first thing. A sub 1 is easy, unless you're that one kid who just doesn't know you plug in a 1, which I know exists this year, because they haven't done anything. So they don't know anything. It's a 1. They like to say, math is hard, I don't get it, but then they do absolutely nothing to fix the issue. You're the issue, not me. You need to fix yourself. Anyways, this is where I am. And I've modeled this in front for you at least 3 times in class by now, not including videos. I just write down what a sub n is. A sub n is the first term plus n minus 1 times the common difference d. This is your difference. I've done that in one of the previous videos. That is your difference. And I have the first term. So the first term is 1. And I use the distributive property. I get 3n minus 3, and don't forget the 1 there. And I get 3n minus 2. That's 3n minus 2. Now, if I combine like terms, what's inside is 3n minus 1. And I've gone from having 2 unknowns to having a singular unknown. So now I'm in business. To clear the fraction, just multiply both sides by 2. 2's cancel. 2 times 925 is 1850. And that's going to equal 3n squared minus n. We're going to shift the 1850 to the right because we want to be able to use ultimately the zero product property at some point in time. And then we're going to sing a silly little song that goes x equals negative b plus or minus square root b squared minus 4ac all over 2a. All right, so let's see what's in there. We have a negative 1 that is squared. We are taking away 4 times 3 times the negative 1850. 22,201, which probably has a square root. Hope so. 149. 1 plus or minus 149 all over 6. 2 times 3 is 6. So I'm going to get either 150 over 6 or I'm going to get negative 148 over 6. Let's see what happens to negative 148 over 6. Do I want to spend time explaining why this is extraneous is the real question. It's a decimal. That's its issue. Plus, if we did negative terms, we would be adding to a negative 925. But 150 over 6 is correct. It's 25. That's my value, 25. All right, write out the nth term for this sequence for negative 4, 2, negative 1/2, 1/4. I know that it's geometric because I'd be taking away 6, and then I'd be adding back 1.5, and then I'd be adding back 3/4. That doesn't make any sense. I know that from working with kids, a lot of us don't know things like you're multiplying by negative 1/2. What I'm doing is I'm looking for the ratio. That's kind of sad, kids. This needs to be fixed, doesn't it? It should be negative 1 followed by 1/2. Let me go back and fix that. Right now, this was technically neither. I'm glad I looked at it real quick. It's one of the reasons why I do this video, is to fix mistakes before you see them. But anyways, we are constantly multiplying by negative 1/2. That is our ratio. Multiply by negative 1/2 as you move right. So my ratio is negative 1/2. And you're supposed to write the nth term, which means you have to know a rule. Since it is geometric, because we are multiplying, that's a really bad looking geometric, is the first term times the ratio raised to the n minus 1. So the nth term is the first term of -4. The ratio is a half, and it's raised to the n minus 1. Now, it is worthy of sometimes giving kids bonus points. It is. Check this out. This negative symbol is attached to a 2 squared, and 1/2 is 2 to the -1st. Still has an exponent of n minus 1. So we're just going to leave that negative symbol out there. Notice I did not put it with the 4. It's just a negative symbol out front. That's all she is. Let's distribute this -1 first. That becomes 2 to the 1 minus n. We have a 2 squared right there multiplied by it. When we multiply like terms, we get to add exponents. So we have a negative out front. 2 plus 1 is 3. And then take away n. Those are equivalent functions. And that is worthy of a bonus point. It, to some degree, looks better. But getting there is kind of hard to do. And I'd love for you guys to just master your exponents. Please tell me I'm recording. Okay, good, I am. All right, 19. Write the nth term of this sequence. 1/2, 3/2, 5/2. What's happening here? Well, this is 0.5. This is 1.5. This is 2.5. We are adding 1. We have a difference of 1 unit. So that means that this is arithmetic. And again, I just talked about this. Some of you, God bless you. If you take 3/2 and you divide it by a half, it's not going to be the same as 5/2 divided by a half. So I know it's not geometric. The ratios are not the same. But if I do 3/2 minus a half, I get 1. And if I do 5/2 minus 3/2, I'm going to get the same thing, 1. So it's arithmetic. So I'm going to use the formula for arithmetic sequence. It says that the nth term is the first term plus parentheses n minus 1 times the common difference d. The first term is a half. The common difference is 1. It's called the distributive property. And combine like terms. And out front, 1/2 minus 1 minus a half. Easy peasy lemon squeezy. So this one's for you farm kids. This is a John Deere X11 combine, almost 800 grand. Decays or depreciates at 18% per year. Write a geometric recursive formula modeling the decay of this John Deere X11 combine. So keep in mind some of the stuff you've already learned. That's decay, right? 1 minus r. So 1 minus 0.18 is 0.82. Now, in our geometric sequences, that's the ratio. You are multiplying by 8200ths as you move right. That makes it shrink at 18% per year. Now, I want the geometric recursive formula. Oh, fudge. Okay, cool. I was afraid this was the actual test. Recursive formula says you get to be the first term if n is 1, and you get to be the ratio, which is 0.82, times the previous term if n is bigger than 1. Part 2, find the value of this combine for each of its 5 years. So in the first year, it's going to be, $799,999. That's not exactly correct, but whatever. It's just a math problem. The second year, it's going to be the previous term times 0.82. So 655,999.18. All right, third year, it's going to be the previous year. That's what this means, previous term. Times 82 hundredths. So 537,919. And how many pennies? 33 cents. And the fourth year is going to be that number right there. 537,919, 33 times 0.82. That's the gist of this stuff. It's not a hard problem. Are a lot of my kids going to miss this one? Oh, yeah, they are. Way too many. So now we're down below six figures, 96,825. Still a very good combine. This is probably not an accurate depreciation model. And 48 cents. And finally, the fifth year. We take that number, we multiply it again by 0.8. Oh, that's not right. That's not right at all. I'm not perfect, am I? 441, 9385. 441, 9385. 441, 9385. I thought that seemed a little low, but I was pushing buttons. We're very guilty of doing things like that. We just push buttons, accept, and we don't think. 361, 69696. Okay, it's not too bad of a model. That does seem fairly reasonable. It does. And keep working backwards. So here we have a description of a pendulum. It is sweeping out an arc of 20 centimeters on its first path. Each successive pass will be 98% of the previous pass. When the pendulum finally stops moving, what is the total distance traveled? This is what you call an infinite series problem. This is your ratio, expressed as a decimal. So the nth term, although it's not even necessary here, but actually I don't even need that. I just need the sum of an infinite series because the pendulum goes back and forth and back and forth. And even when we look at it, it's still vibrating, even though it appears still. It's still moving just a little bit. It eventually stops to some degree, although nothing really ever stops moving. But the sum of an infinite series is the first term over 1 minus r. All right. First term, 20 centimeters. 1 minus r, 0.98. And, you know, if you want to do this in here, this is 20 over 0.02. And that's going to be 1,000. I know you don't believe me. But 20 divided by 1 minus 0.98 is 1,000. 1,000 centimeters. 16, given the sequence below is geometric, which means we move from left to right through multiplication to find the first term. So this is ace of 3, 4, 5, 6, 7. This is ace of 7. You might have some luck just playing around with numbers, like what do you multiply by? Like I think the correct answer is 5, 25, 125, 625. It is. But the fail-safe way of doing this is to think about the nth term of a geometric sequence. That is the fail-safe. So this guy's 5, and it must be equal to the first term times the ratio to 3 minus 1, which is 2. This guy is 3125, and it must be equal to the first term times the ratio, 7 minus 1 to the 6th power. Always solve the smaller equation for ace of 1. So ace of 1 is 5 over r squared. 3125 equals 5 over r squared times r to the 6th. 3125 equals 5 r to the 4th, because you think about this. 6 minus 2 is 4. Divide out the 5, and I'm pretty sure you'll get 625. 625 is r to the fourth, so r is the fourth root of 625, because the opposite of the fourth power is the reciprocal, 1/4. And again, that should be a 5. And it is. So the ratio is a 5. Go back and plug this in. The first term is 5 over a 5 squared, which is 5 over a 25, which is 1/5. That was the goal. Probably gonna stop at 15 because I've got about 3 days of grading I need to start on. So, weapons grade plutonium has a half-life of 24,100 years. If 4,000 pounds of unused plutonium were put in deep storage, how long until there's only 5 pounds of weapon grade plutonium left? So our formula for half-life is that the amount after time left is the principal times 1/2 to the t over the half-life time. So my goal is to get to 5. It would be the principal of 4,000 times 1/2 to some unknown time over the half-life of plutonium, 24,100. From here, it's a y1, y2 kind of deal. Lots of kids are going to miss this problem. And it's my fault, right? Cool. I'd already done something similar to this one there. I'll put a 5 there. I'll do a zoom 6, even though it's useless. Now, this thing has a half-life of 24,100 years, so you're going to want to go out several 100,000 years. I'm going to go out 500,000 years. So I'm going to set my X max to be 500,000 years. And I'm going to hope that's enough. If not, I'll just make it bigger. That's how this works. But it was enough. Second trace for the upteenth bajillionth time in this room. Enter, enter, enter. 232,417 years. I'm just going to round the nearest year. 232,417. You know what? I'll do some more. Even though I'm getting kind of tired. Solve using change of base and the graphing ability of your TI-84. So do remember your change of base formulas. A logarithm base b argument a is a natural log of a over a natural log of b. You got this 2 there. Okay, so we're just going to leave that up top. 2 ln's of 4x plus 2 over the ln of 7. Don't move that 2 as an exponent. For some reason, the TI-84s don't do them right. This guy is going to be the ln of 2x plus 3. So now over the ln of 3. And plus a 2. And you'll notice I forgot something right there. I need a plus a 4, right? Most of you, 90% plus, can do this. It's a shame it's not one of those all kids can do. Let's do this the safe way. Math, num, n over d. 2 natural logs, 4x plus a 2. Sitting over the natural log of a 7. Then we have a plus a 4. Down to y2. Natural logs of 2x plus 3. Oops, I didn't do the safe way. Math, num, I'm old school. So doing things new ways sometimes, they're not my choice. I'm so old school, I would be doing this by hand, to be honest with you. Just because it's fun. Zoom 6. And there's your answer. So what do we have? Second trace 5. Enter, enter, enter. 0.4299. Well, I'm wearing out. I really need to finish this whole twin, regardless of grading. All right, so 13. What yearly rate of interest is required to quadruple an investment in 7 years? The very easiest thing you can do is you can make your principal $1. And then after some time passes, it's going to quadruple. It's going to become $4. And we're just going to plug into the formula for growth principal times 1 plus r to the t. So 1 plus r to the 7th, because there's an understood 1 there because we invested in 1. The opposite of the 7th power is its reciprocal, the 1/7. So my next line would say 4 to the 1/7 is 1 plus r. We just subtract 1. 4 to the 1/7 minus a 1 is my rate. Let's see what that is. 4 to the 1/7 minus a 1.2190. Or 21.90%. Easy peasy, lemon squeezy. 12, solve for x by rewriting each side such as the bases are common and setting exponents equal to each other. So you do have to have some number sense here. 125 is a 5 cubed. 1/5 is a 5 to the negative first. Because think about it like this, 1 over 5 to the first is equal to 5 to the negative first. Think about it like that. We already have 5x plus 1 up top. So since the bases are common, we don't strike them out. We just ignore them. 3 equals negative 5x minus 1. Add 1. 4 equals negative 5x. Don't know why I wrote it that way. Divide out the negative 5 from both sides, and x is a negative 4/5. 11. Solve by exponentiating. But first you isolate. You have to isolate first. Why is that such a hard concept? You have to isolate first. So we're going to subtract 4. We do easy stuff first. 3 log bases of 3 of 2x minus 1 is a 12. Divide out that 3, not that 3, that 3. And a log base 3 of 2x minus 1 is a 4. Base, argument, exponent. 3 to the 4th is 2x minus 1. The number of you who can't do log is bay yet. We've been doing it for a month. It's driving me insane. 3 to the 4th is 81. If you don't believe me, push the buttons. 3 to the 4th, or maybe you start memorizing things. It's 81 equals 2x minus 1. Add 1, you get 82. 82 is twice x. Divide by 2, and x is a 41. Number 10, solve again by isolating and converting into a logarithm. So we're going to subtract 4 and get an 8. 4e to the 3x plus a 2. Divide out that 4. E to the 3x plus a 2 is now a 2. Now it's isolated. Base, exponent, argument. A logarithm of base e, whose argument is 2, is equal to 3x plus a 2. Log base e is more affectionately known as a natural log. We're going to take away that 2, is the opposite of addition and subtraction, and then we're going to divide out that 3. So the natural log of 2 minus 2 over 3 is my x value. See how easy these are? I'm on like autopilot here. Solve by taking the ln, both sides, isolate first. Subtract 5. 5 is 40 times 4 to the x. Divide by 40. 1/8 is 4 to the x. Now, ln both sides. The natural log of 1/8 is equal to the natural log of 4 to the x. Remember, exponents go to the front. X natural logs of 4 on the right is what you have. And then we divide by the natural log of 4. I would accept that answer. I would like to see also the natural log of 1 minus the natural log of 8 over the natural log of 4. This is just a better looking answer. Natural log of 1 is a 0. So I could just say it's equal to a negative natural log of 8 over a natural log of 4. I could say that. This is better. Let's just put a big smiley face there. All right, best form. Smellyville. Decaying at a rate of 23% every 3 years. If the current population is 75,000, part 1, write a model for Smellyville. It is decaying, so I'm plugging into the formula for decay, principal times 1 minus r to the t. And we also have this every. That comes back into play. Why we can't accept how that works is beyond me. 1 minus 0.23 is 0.77 to the t over a 3. Convert your smelly 3-year model into a smelly yearly model. What we're going to do is we're going to move for the upteenth time the 1/3 inside and leave the t on the outside. And then we're going to go to our t84. We're going to do 0.77. We're going to raise it to the 1/3 power. And we're going to get 0.9166. 75,000.9166 to the t. What is Smellyville's annual decay rate? Another thing that I've mentioned time after time after time is how 1 minus r lines up with 0.9166. Do some shifting, kids. R is 1 minus 0.9166, which is 0.0834, I believe. I feel like that's right, but I'm pretty darn tired. 0.0834. When will there be just one smelly person left in Smellyville? So use your equation from 1. 1 equals 75,000.77 to the t over 3. It won't take that long. Town's shrinking pretty quick because it smells. Everybody smells. So these smelly people are going to leave Smellyville and go stink up some other town. That's exactly what's going to happen. Anyways, I'm going to do Zoom 6 because the last time I played with the calculator, I had a 500,000 year X max. Now, I'm not going to see anything within 10 years. That's just, you know, too soon. Although it'll be down to what? It'll be down to 8,000 or so. I'm only going to go out 100 years. I think it'll happen with 100. That'll be 33 halvings. And I'm waiting. It didn't happen within 100 years. Huh. Okay, 500 years. And there she is, my intersection. Second trace 5. Enter, enter, enter. 120.84572. 128. 84572. So here's the bonus. I have 128 years. .854572. There's 365 days in a year, so 311 days. We'll take away the 311 whole days. I'm going to convert this partial day into an hour, 24 hours in a day, 22 hours. I'm going to take away the 22 whole hours, and I'm going to convert this partial hour into a minute by multiplying by 60. 3 minutes. Let's take away the 3 entire minutes, and let's convert the rest of it to seconds. There are 60 seconds in a minute. We'll call that 3 seconds, because it was 2.59, so 3 seconds. I really don't want to go into the concept of milliseconds. All right, so the hydrogen sulfide one. A particular young male who happens to be in my 3rd period class is lactose intolerant, likes to drink several cartons of chocolate milk during class. After his 3rd little carton of milk, he has a moment of flatulence with a hydrogen sulfide concentration of 1.25 parts per million. His buddies join in. Suddenly the room has a hydrogen sulfide concentration of 52.55 ppm. This is where your skin starts itching. That's itchy skin. How long after this episode of mass organized flatulent or third period eyes no longer be sore? So I want to get below 10. All right. So the setup here looks like this, where the amount, 52.5 e to the negative 0.2 tenths of t, is less than 10. That's the setup. And you're allowed to use y1, y2. So 10 in y1, 52.5 e to the negative 0.2 x. We'll do a zoom 6. We'll probably have to look to the right. We'll probably look up too, just to make the graph look better. Oh, it actually happened. Right there, 8.2911 minutes. What was it, 1404? That's going to be 8 minutes. And let's take that 0.29, 11404, and multiply it by 60 to get seconds. 17 seconds. So it's actually an inequality when the time is greater than that. Not a single kid answered that question with an inequality. It's where time is greater than. So at 8 minutes, 18 seconds, your eyes quit hurting, although the room still stinks bad. 6, some of you guys don't raise hogs. This actually used to be a problem back in the days of raising hogs. The buildup would be so high, you'd come in and all your hogs would be dead, and you died too. Crazy, huh? You'd walk in, you would be like, why are all these animals dead? And then bam, there you go. Because if ppm hits this, and this used to be an issue, you had open lagoons and stuff, and then shifting, immediate unconsciousness as soon as you open the door. It used to be an issue. Find the sum. It does say decide if I'm arithmetic or not. What is this one? And this one goes on forever. Forever. This one has a ratio. The ratio here is -1/2. And it goes on forever. Eventually it reaches infinity. So this is an infinite sum problem. The sum of infinity is the first term over 1 minus r. The first term is 4. It's over 1 minus the common ratio of 1/2. This would be 4 over 3/2, which would be 8/3. I know you're like, Milbrath, what did you just do? Like, what evil thing did you just do? Well, let's see if I'm right. 1 minus a -1/2. So 4 sitting over that. Math, enter. 8/3. I know how to work with fractions. That's what I just did. You should probably learn them too. Find the sum of the 4th through the 12th terms of the sequence 4n minus 3. Am I arithmetic or geometric? I'm arithmetic because I look like mx plus b. And I'm going to use my summation formula. N is always high, minus low, add 1 back. So there are 9 terms. The first term happens when you plug in a 4. It's actually called ace of 4. It's 4 times a 4 minus a 3, which is 13. Plus the last term, which happens when you plug in a 12. 4 times a 12 minus a 3, which is 45. And I don't know how much of this you care to do in your head, but 13 and 45 is going to be a 58. 9 over 2 times a 58. Half of 58, as tired as I am, I feel like it's 29. This is 9/29, so that's 180 plus 81. Which is 261. So let's check me because it is early in the morning and I'm tired. We had a 9 over 2. We were multiplying that by 13 plus 45. 261. Almost done. Your broke butt needs $1,700 to buy a used 2001 Ford Ranger because of your lackluster work ethic and 0.92 GPA, which caused you to drop out of high school. You work at Dollar General making minimum wage and have 0 credit. you have to borrow, it's so bad that the bank is giving you a 7-year loan at 12% interest. You're gonna pay more interest than the value of this Ford Ranger. Since you dropped out of high school, doesn't like you'll be able to solve this, but what will you owe the bank and what will your monthly payment be? So you're gonna use this guy for, I don't know, we've been doing this guy for a month, compound interest formula. Some of you still have not figured these things out. Like, it is ridiculous. How many times do you have to be shown the correct way of doing something? The issue is you're not trying to do it on your own. That's the issue. It's not hard. You borrowed $1,699. The rate of interest, 0.1119. That said to me Wednesday. Monthly, N is 12 months per year. The exponent is NT, 12 times 7. So let's see what you owe after 7 years. And it's going to be a chunk. It's going to be way more than what you paid for the thing. Poor people don't understand the cost of borrowing money. If you don't know 12 times 7 is 84, don't worry, your calculator won't judge you. 38.92 and a nickel. So the interest alone was $2,100 and some change, right? Paid more in interest than you did for the actual vehicle. Your monthly payment, you take that value, you figure out that 7 years is 7 times 12, 84 months. So you divide by 84. Your monthly payment's not going to be that bad. And in 7 years, you'll own a 2001 Ford Ranger, $46.33. So if it's 2025 now, in 2032, you will own a 2001 Ford Ranger. Ugh, you poor kid. I feel for you. It's kind of funny though. Poverty. 46.33. All right, moving back to 4. Find the inverse of y equals log base 5 of x plus 2 minus 7. First thing you do on inverses is you swap x and y. So x equals log base 5 of x plus 2 minus 7. Step 2 is to resolve for y. So we're going to add 7 to both sides. X plus 7 is log base 5 of y plus 2. And we're ready to become a exponential. Base, argument, exponent. 5 to the x plus 7 is equal to y plus 2. Isolation. 5 to the x plus 7, take away 2 on the level, not as an exponent space, is y. There's your inverse. Number 3, evaluate log base 5 of 25 of 6y by hand, preferably. Really, that's the only way you can do it. This is asking what power, I'm going to do this 2 ways, of 5 equals 25 to the 6y. So 5 to some power is equal to 25 is 5 squared. 5 squared times 6y. 5 to the question mark is 5 to the 12y. There's my answer. That's one way of doing it. The other way of doing it is to take your exponent and move it out front. 6y times log base 5 of 25 is my answer. And, do change your base or whatever if you can't answer that in your head. But that should be a 2, right? Because it just was a 2. I'm making mistakes when I type. That should be a 5. I'm getting the sewing again. And I find that this piece is 2. So 6y times 2 is 12y. 2 to go. Solve for x. Log base 8 of x plus 6 plus log base 8 of x plus 4 is 1. I know that if I have 2 logarithms and I add them together, that the summation becomes the product of a singular log. So I get to condense and have a singular log base 8, and she contains x plus 6 times x plus 4, and she's still equal to 1. I'm going to go ahead and do log as base, argument, exponent. 8 to the first is the product here, x squared plus 6x plus 4x plus 10x plus 24. I'm going to subtract 8. 0 equals x squared plus 10x plus 16. I'm going to factor because it's my favorite F word. X plus 8x plus 2 equals 0. I'm going to use the zero product property. X is negative 8, x is negative 2. I know that a logarithm must have an argument bigger than 0. So if I plug the negative 8 in, I'd have a negative 2, and it fails. That guy is extraneous. If I plug a negative 2 in, it works, real. And the first one, find the solution of the equation log base x of 128 is 2. Of course, you have to simplify your radical on that one. Base, argument, exponent, x squared is 128. X is therefore the square root of 128. 128 is 64 times 2. The square root of 64 is 8. 8 root 2. It's actually technically plus or minus, but we only keep the plus. Talk about that. And there is your next twin.